use minerals in our everyday lives. Take a look around. Minerals are everywhere. Copper in electric wiring, gold, silver, and diamonds in jewelry, graphite in pencils, and even salt, which is a mineral too, is used in food seasoning. At the present time, we know more than 5,000 minerals, and this wide variety induces the questions: what is a mineral? And what properties distinguish one mineral from another? With enough experience, a mineral can often be accurately identified by simply viewing it. So, what is a mineral? The term mineral has different meanings for different people, but we will focus on the meaning that geologists apply to minerals. Minerals, by definition, are any naturally occurring chemical compounds or individual elements, homogeneous in chemical composition and internal structure. Additionally, minerals are characterized by an exact crystal structure and can be represented by a chemical formula. Minerals formed as a result of various physico-chemical processes that take place in the Earth's crust and on its surface. The properties of minerals depend on their chemical composition and internal structure. Chemical structure of minerals can be exact or can vary within limits. The precise examination of minerals is performed using various methods: chemical, spectral, X-ray structural, electron microscopic, and other types of analysis. But these methods require preliminary preparation and often the use of expensive equipment and special techniques. However, knowledge of the properties of all 5,000 minerals is not necessary, because many of them are quite rare, and the number of minerals that are prevailing in the Earth crust is only about 70. Identification of these minerals with sufficient level of accuracy is possible through determination of the complex of distinctive physical properties without use of laborious research. Basically, we will consider those properties that can be used in visual diagnostics of minerals, called diagnostic properties. Minerals can be identified by conducting a few simple, costless tests. Once a person becomes experienced in this field, he can usually identify a mineral by observing it and taking into account its specific features, such as color and crystal formation. So, diagnostic properties are properties that allow identifying the main rock-forming minerals, as a rule, visually, without the use of complex instruments and chemical analysis. The groups of diagnostic properties are the next ones: optical properties, color, luster, transparency, streak; mechanical properties, hardness, cleavage, fracture, brittleness; chemical properties, water solubility or taste, and reaction with hydrochloric acid; additional properties, magnetic properties, specific gravity. In details, the properties of each group will be discussed later. You should keep in mind that some physical properties may be identical for different minerals, for example, color or density, and vice versa. Some properties may vary for the one mineral. Thus, during the microdiagnostics of the mineral, it is necessary to establish as many properties as possible. Cases where a certain property makes it possible to identify a mineral firmly, for example, magnetic properties of magnetite, are the exceptions to the rule and cannot be extended to the whole variety of minerals. Consider the mineral classification. At the heart of the modern minerals classification are chemical and structural features. Presently, crystal chemical classification of minerals is accepted in mineralogy. The largest systematic unit is a type that unites minerals with a close character of chemical compounds and with closely related types of chemical bond. In total, there are 4 types of minerals: native elements, sulfides and analogues, halides, and oxygen compounds. Types are divided into classes that combine minerals with closer chemical properties and type of bond. What do we know about each type of minerals? Humanity is aware about 80 representatives of native elements, mainly metals, most of which are very rare. The noble metals, as platinum, gold, and silver, are most widespread in a native form. All native elements can be divided into 4 main classes: Metals like copper, gold, silver, platinum. Semi-metals, bismuth, arsenic, antimony. Non-metals, sulfur, graphite, diamond. And intermetallic compounds. Contribution of native elements to the weight of Earth crusts is 0.1%. The type of sulfides and analogues include sulfurous, selenious, tellurious, arsenious, and antimonious compounds of metals and semi-metals. The sulfide minerals are a class of minerals containing sulfide as a major anion. Sulfur compounds, sulfides and sulfur salts, represent the main part of minerals. Most sulfides are characterized by strong metallic luster, excepting sphalerite and cinnabar. Black streak, exceptions are the same. Higher density, more than 4 grams per cubic centimeter, and low, less than 5, hardness, except for pyrite and arsenic pyrite. High electrical conductivity and semiconductor properties as well. Nowadays, more than 250 mineral species are classified as sulfides, but their total content in the Earth's crust is small and doesn't exceed 0.15%. Only 20 of them are widely distributed and met in large amount. Pyrite and pyrrhotite, which constitute about 4/5 of all the sulfides known to us, are most common. The vast majority of minerals, about 200, are rare and absorbed in small amount. Halides are compounds containing halogens. The halide class includes minerals with a halogen as a major anion: fluorine, chlorine, iodine, or bromine, and alkaline or alkaline earth elements as cation. About 100 halide minerals are known. The total weight of halides in the Earth's crust doesn't exceed 0.5%. Chlorine and fluorine compounds represent the great part of halides. On the contrary, iodine and bromine compounds practically do not form individual minerals and are extremely rare. The bulk of the halides is colorless or has a white color with a greenish or yellowish tinge. Chlorides of lithophilic elements are highly soluble in water, whereas fluorides are insoluble. Most halides have glassy luster and low hardness. They are transparent and exhibit the perfect cleavage. The most common chloride, halide, is the main compound dissolved in the ocean water. And the last type, oxygen compounds. This type of minerals is the most extensive, including several classes and subclasses. Compounds of metals and metalloids with oxygen represent the first class, oxides and hydroxides. Oxides have had about 300 mineral species, hydroxides more than 80. They constitute 17% of the lithosphere weight. A significant part of the oxides is colorless or slightly colored, as is typical for ionic compounds. Oxides containing iron, manganese, titanium, tantalum have black or dark brown coloration. Most oxides have an average hardness from 5 to 6, but some of them are really hard. For example, corundum with hardness of 9. Carbonates are widespread minerals, although about 80 minerals of this class are known. Most carbonates have perfect cleavage and a typical glassy luster. The average hardness is about 3, ranging from 1 to 4. The majority of carbonates are colorless or white-colored. The class of sulfides includes natural salts of sulfuric acid. They have had about 200 minerals. Most sulfides are colorless or white and transparent. Many sulfides, for example, barite, celestite, anhydrite, have a blue color. These minerals are soft. The hardness usually doesn't exceed 3.5. Many sulfides are water-soluble. The salts of tungstic acid form a class of minerals named tungstates. The amount of these minerals is small, but they are used as valuable ores for the tungsten production. The phosphate class combines salts of phosphorus, arsenic, and vanadium acids and has more than 300 minerals. Bright coloration distinguishes many of these minerals. Most phosphates have low and medium hardness. It rarely reaches a value of 5. The last class is silicates and aluminosilicates. The total number of silicate mineral species is about 800. The share of silicates is 75% of all minerals in the lithosphere. Silicates and aluminosilicates are the most important rock-forming minerals.